Hi, your next challenge is entitled Check if string ending matches second string. The instructions are to create a function that takes two strings and returns true if the first string ends with the second string, otherwise return false. This is made clear in the examples below. You can see that the first is true because ABC ends with BC. Number 2 is false. Clearly D is not at the end of this. There's a C there. Check ending samurai in ZI is also false. Notice that the ending is AI for 2 letters, and they had ZI. With 4 letters, 9, you take the last 4 of feminine, and that is a match, so return true. TO is 3 letters, you take the last 3 letters and it does not match. That's kind of a cool test because, it's close. It is contained in the word, very close to the end, but it's not at the very end that we require, so the result is false. Hopefully that's clear at this point. We'll head over to the code. Now's your chance to pause and try this out. I think this is a pretty good challenge at this point. Okay, so I'll do the usual. We'll kind of do the naive implementation to start, and then I'll show you the nice short way of doing it. It's a lot less work. So to sort of describe the approach I'm going to take for the first implementation, I essentially am going to iterate over the string going backwards. Normally we kind of always increment our index. We start at 0 and go up. But in this case, since we're looking at the end, I'm going to start at the end, go back 1, go back 2, and I'm going to be reading these characters in reverse and making sure that they match also in reverse on string 2's side. And then at each stage, I'm going to compare them. Is C equal to C? It is. Okay, we'll stay alive. We'll keep looking. Is B equal to B? Yeah, it is. We're alive. We're still looking. In this case, since we exhausted the entire second string, B and C, there were no violations. I would return true in my algorithm. But consider, one of these false cases where we're going to start at the back. Is I equal to I? Yeah, it is. Okay, we survive. We go to the second iteration. Is Z equal to A? No, clearly it's not. I'm going to say automatically return false. Once there's been one violation, I'm out of the loop and I'm done. I'm saying the first string does not end with the second. So hopefully that makes clear the kind of approach I'm going to take to doing this. So I've stressed in the past the importance of validating input. You don't have to here. They're going to give you well-formed stuff, but kind of like to address that anyway. So if we get a weird scenario where string 2 size or length is greater than that of size 1, we're going to return false. Clearly string 1 can't end in string 2 if it's longer. And then to be safe, we could check that string is null or empty string 1, just to make sure that we actually have input there, or essentially doing the same thing with string 2. If there's nothing there, and it could depend on your definition. This would be a good edge case to try. If they're both empty, do you say it ends? I guess I would think not, but maybe someone would want that case to return true. This is where you kind of have to ask the people in charge what they're looking for. But we shouldn't hit any of these cases. We could even maybe just check the second one. Make sure you do your due diligence there and cover all the weird potential inputs that you could get. So next, we're going to have to set up traversing the loop backwards, and this will be a good exercise because you so often see it going forward that it's good to do it the other way and realize that you're not stuck having to go forward, having to increment the loop by 1 every time, things like that. You can customize these however you like. So we're going to go the opposite way. We're going to go string2.length, then I is greater than 0, and we're going to subtract I. So this is going to read right off the back of string 2. And we essentially only have to get through string 2. Once we've validated all of that, we're good. String 1's longer, but we don't need to keep looking because there's nothing to compare with anymore. So I'm also going to maintain this separate index for string 1. Actually, no, scratch that. Okay, string 2.length. Then, if we start reading off the back this way, we can say if string 2I is not equal to yeah, actually, I'm sorry, I did have to do that because string 2 and string 1 lengths are not the same. So let's give a separate index for string 1. String 1.length minus 1 to get the last element, and we'll call it string 1 index equals that. That's going to give us the last valid index in string 1. And we'll update that in our for loop as required. So we're going to use this I, which is based on string 2. We're going to compare that with string 1 and string 1 index. So this is going to take the last item in string 1, the last character, and compare it against the last character in string 2. If they don't match, we're going to say return false. That's not an ending that they're looking for. Otherwise, assuming it is a match, you'll get down here, and we'll have to update our string 1 index here. This will decrement it by 1 and move toward the beginning of the string and grab the next character in the direction of the beginning. And that'll happen here as well for string 2. See, its variable is being updated here, but we got to do it separately for string 1. So, assuming we get all the way through string 2's length, then we have a match, and we'll say return true. And I think we're good here. We can give this a run. Let me add system. Okay. Okay, index out of range. Oh yeah, there you go. It's outside the bounds of the array. So maybe take a look if you want to pause and see what I did wrong. Go ahead. Otherwise, I will say that we started at length. And remember, length minus 1 is the first valid index going from the back. So what I needed to do here was I needed to take I minus 1 to get that. And I used the length because you can imagine if the length of string 2 is only 1 letter, like we saw in the example, if I used length minus 1, it would have I equal to 0 to start, and then it's requiring I to be greater than 0, and we'd never even get in the loop. So that's how I'm getting around that here. Let's see if this is any better. Okay, yeah, there you have it. We went from the back. We tried to validate our input to start, catch any weird cases, and exit right away if there's a problem. Then we set up our loop to go through the strings going backwards from the end. I had to make this separate index for string 1 because it can have a different length than string 2, often does. And then yeah, we're essentially matching characters one at a time from the back, and if at any point we find a violation, we're out and we say no dice, this is not a match. Provided we make it all the way through with no violations, we're saying, hey, this is good, return true. hopefully that's clear. And now let's try it the proper way, the nice way, the way I'd actually do this. Now is a good chance to pause. I'm gonna refresh, have a go. It involves using a tool we've used in the past already. That'll be a hint for you. And it is our good old friend, system text regular expressions. And if you remember, we use these to validate string input. We're going to do that here. We're going to make a pattern to use. Pattern equals. And the pattern is mostly defined for us by string 2, right? But the problem is I can't use it as is because it will find string 2 occurrences anywhere in the length of string 1. And we specifically want to check only at the end. So if you remember, there was a special character we used to denote the end of the text being searched. And that was the $. And you can look those up again to understand some of those special characters with regular expressions from the links provided previously, or just ask a question and I'll direct you as desired. So then we can make this return regex match string 1 pattern. Check our pattern against string 1. I think this might, wait, no, remember there was that success. I think we might have to do that if it's successful. Let's try this. And look at that. The old 2-liner. I mean, we couldn't even not even use the temporary variable here. But isn't that sweet? That was a lot less work. You can imagine as problems get more complex, how powerful these regular expressions are and how much trouble they can save you. So I would highly recommend this, and hopefully that's a little more incentive for learning regular expressions. And as usual, hit me up with questions, comments. If anything is unclear, feel free to share your solutions. Those are always appreciated too. Thanks for watching.